Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are diving into the world of personalized content recommendation. This episode is based on a tech blog titled Advancements in Embedding-Based Retrieval at Pinterest Home Feed, written by their engineering team. You can find the link in this episode's description. Throughout this episode, we will explore this topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Pinterest is a global visual discovery platform where users explore and save ideas across topics like home decor, food, fashion, and travel. With over 570 million monthly active users worldwide, Pinterest needs to ensure that its users are consistently engaged by seeing content that feels fresh, personalized, and relevant. At the heart of Pinterest's product is the home feed, which is a dynamic stream of recommended pins tailored for each user's preferences. The better Pinterest gets at recommending the right pins, the more likely users are to stay on the app. Then they can discover new content, take actions like saving or clicking on the pins. These downstream actions are directly tied to Pinterest's core business metrics. But personalizing content at this scale is no small feat. Every day, Pinterest needs to serve billions of candidate pins to users around the world, factoring in their interests, intent, and the latest trends. To handle this, Pinterest relies heavily on its retrieval system, which is responsible for quickly narrowing down the massive corpus of pins to a manageable set of highly relevant candidates. This retrieval system plays a foundation role in the full recommendation pipeline. If it can't surface good options quickly, the downstream ranking models, no matter how advanced it is, won't have much to work with. That's why Pinterest engineering team continually invests in improving this system, both in terms of model quality and serving infrastructure. Now that we've outlined the business problem, let's shift our focus to the technical side and explore how Pinterest tackled this challenge using embedding-based retrieval. To begin with, it's important to understand the foundation of the current retrieval system. At its core, the goal is to surface highly relevant pins by learning subtle and complex patterns in user behavior. To do this effectively, the model ingests a wide range of input features, everything from pre-trained embeddings to categorical or numerical signals, that help capture both obvious and hidden indicators of user interest. A key part of Pinterest architecture is the two-tower neural network design, which is commonly used in large-scale recommendation systems. In this setup, two separate neural networks operate in parallel. One processes features from the user side, and the other processes features from the content side. In Pinterest's case, it's a pin. Each tower encodes its input into a dense embedding, and these embeddings are then compared using a single similarity operation, typically a dot product, to estimate the likelihood of the user engagement. This structure is elegant and effective. It balances scalability with strong performance, and serving as a solid baseline for personalized retrieval at scale. But the team didn't stop at this baseline. They introduced a series of targeted improvements to further boost the retrieval quality, and these innovations span several key areas. The first area focuses on enriching feature interactions within each tower. In the world of recommendation system, a well-established insight is that crossing features, essentially modeling how two features interact, can significantly enhance predictive power. For example, in the world of content recommendation for movies, knowing a movie's genre is helpful, but knowing the combination of genre and director provides much deeper context. While the standard two-tower model introduces basic interactions through a dot product between the user and the content towers, the team realized that additional gains could be unlocked by increasing the complexity within each tower itself. Since the pin tower is run offline, and the user tower is fetched only once per home feed request, the team had room to expand the model's complexity. They started by incorporating a model called MaskNet, which is designed for bitwise feature crossing. Building on top of that, the team also adopted the DHEN framework, which is in short for Deep and Hierarchical Ensembling Network. And this architecture stacks multiple layers of feature crossing models both in series and in parallel. It allows the model to capture high-order interactions from different angles while keeping the system efficient. These improvements led to an impressive 0.4% lift in engaged sessions, which is a meaningful result given Pinterest scale. The second area of innovation centers on improving ID embeddings. These embeddings capture user and item level history. So, for instance, a user often engages with food and recipe pins will have an embedding that reflects this preference. While effective to capture all the information, ID embeddings are vulnerable to overfitting, especially when historical data is sparse. To overcome this challenge, Pinterest deploys this contrastive learning to pre-train large-scale user and pin ID embeddings. This technique teaches the model to differentiate between positive and negative engagement examples using a large diverse dataset drawn from multiple Pinterest surfaces. The result is a more robust and generalizable embedding that improves downstream model flexibility and performance. The third improvement area lies in the serving corpus, which is the candidate pool from which recommendations are retrieved from. A model can only be as good as the data it has access to, and the team found out that revisiting how they constructed this pool was a high leverageable opportunity. Originally, their serving corpus prioritized the pins that had accumulated the most engagement over the past 90 days, based on a canonical image signature. But this approach sometimes lagged behind emerging trends. To address this problem, they introduced a time-decayed engagement score, which gives more weight to recent interactions. In this way, the pins that are just beginning to gain traction can still be surfaced prominently, even if their overall engagement is still catching up. This adjustment, although very simple, led to an additional 0.2% increase in engaged sessions. This is all done without even touching the underlying model architecture. Looking ahead, the team is actively exploring even more advanced retrieval technologies. Among these approaches being invested are capsule network, conditional retrieval models. Both techniques represent promising directions to further personalize recommendations and enhance the user experience. Now that we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we explored how Pinterest is advancing its embedding-based retrieval system to power a more personalized, relevant, and dynamic home feed experience. By scaling up their model with richer feature interactions, keeping the content corpus fresh with trending pins, and applying cutting-edge machine learning techniques, the team is able to deliver better content, faster and more accurately to hundreds of millions of users. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.